All right. Good morning, everyone. We're going to have to move on. We've done domain and range from equations, so we're going to have to look at them from graphs as well. This is pretty easy to look at. Let's look at this function. F of x equals absolute value of x plus 2 minus 1. The arrows on the ends tell us that this goes on infinitely left and right. Infinitely left and right. So the domain is all real numbers, right? All real numbers. What does that look like? Well, if we went over here, this is that same function. If I scroll in, I get closer, but I can scroll out as far as I want. Notice the x values all the way 800, and they would go on that side as well. So I could go all the way out and back to where it was. So it's just showing you that it's all real numbers. All right, that's good. So that's the domain. So what about the range? Well, for the range, we can look at the lowest or the highest point in the graph. In this case, that's point -1, -2. That's right down here. This point here, -1, -2. Since the range is a set of all possible y values, right, we're going to write that y is greater than or equal to -1. Get this. Oops. I guess I could have done that. Right. That's the lowest point. All the y values are above that. Everything above that. Everything above that. There are no y values down here. So our range will be y such that y is greater than or equal to -1. Sometimes we're going to be looking at a portion of a function, a little piece of a graph. In this case, we draw some lines on it. It's the best way to see it. Top, bottom, left, and right to find our domain and range. So here we have a portion of that previous graph. It stops here. We have points there, A and B. We have this point down here, didn't label it, but we know where that is. That's -2, -1. So what do I mean about drawing lines? Blue dashed lines indicate the leftmost and rightmost points on the graph. There's no lines there now, but that's what I'm about to put in. And I'm going to make them dashed, and I'm going to make them blue. Right? So I have this side, and I have this side. That's our domain. Where is our domain from? Our domain is from here to here, these two places. Right? That's from -6 to 2. So we're going to write the domain is x such that x, now here we're going to write an inequality. An inequality is going to have these symbols in it, less than or equal to or less than. Lowest number comes first. Always face these things towards the left. It's easier to remember that way. We're talking about domain, so it's the x's and the biggest numbers on the right. So our domain, looking at this graphically, is x such that x is between -6 and 2. And what about the range? Well, the range, we want the lowest and the highest, right? The lowest and the highest. So again, the easiest way to see this is with dashed lines, right? Is it still dashed? I hope so. Yeah, no, it's not. Of course not. All right. So, whatever. Yeah, let me undo that. I want it to be red. I said red. Let's make it red. Right? The highest point is there. That would be 3. Our lowest point is here. That would be -1. So our range in this piece of this function is y such that y is between, y is greater than or equal to negative 1, less than or equal to 3. Open circles. Sometimes the piece of the graph is going to have an open circle like this here, right? You're going to see an open circle. An open circle means that that point is not part of the graph, not part of the graph. So this changes our inequality. Our inequality, we're still talking about our range, domain and range, is from left to right. But on the left side, 6 is now not part of it. So instead of x is greater than or equal to negative 6, x is going to be greater than negative 6. Just greater than. Because this open circle means it is not part of the graph. At B, it's a closed circle, still part of the graph, so it's less than or equal to 2. How does that change our range? Well, be careful here. Even though this point is not part of the graph, B is, and they're both at 3. So if one is part of the graph, the other one isn't, we still take the one that is. So if you have two circles, we use the one that's filled in. So our range is exactly what it was before. Y such that y is greater than or equal to negative 1, less than or equal to 6. Because 6 would be a solution here. It's not two solutions, it's just one. All right, let's look at the linear function. F of x equals 2x plus 4. Again, the arrows tell us it goes on infinitely, left and right. So the domain is going to be all real numbers. Also, there's no minimum, so the range is also all real numbers. This is always true for any linear function. If you're asked for the domain and range of some linear function, it's always all real numbers for both. So how would you find the domain and range of this portion of the previous function? Oh yeah, I'm quiet now because you should be trying to figure this out on your own. And I will give you a minute or two to try that. Again, you're going to be drawing those lines. And the lines are just helpful guides, so you get an idea of where you're at. You should have done something like this or looked at something like this. All right, what is that between? Negative 4 and where am I? It should be 1. It's a little off because this thing didn't snap to it, but in our range, right, from here to here. So this little box here is what our range is going to be. Our domain is x, such that x is greater than or equal to negative 4 over here. There's our negative 4, as high as 1. And our domain goes down as low as negative 4, as high as 6. So our domain would be x greater than or equal to negative 4, less than or equal to 1. Range is y such that y is greater than or equal to negative 4, less than or equal to 6. Now I'm going to be looking at a couple of functions. What changes in this one? Well, this is the same as the last one, except notice here I have an open circle. That means that that point, negative 4, is not part of the graph. Not part of the graph. So how does that change things? Whoop, I should have copied it. I didn't. I'll copy it right now. Copy, paste. All right, so how does that change things? Well, look at our domain. X is greater than or equal to -4. That was when it wasn't an open circle, but it is an open circle. So what's going to change here? This is going to change. Ooh, come on. Thank you. Instead of greater than or equal to, I just have greater than. 1 is still part of it. And same thing on this one. It is just greater than because of this open circle. Here's a quadratic function. The domain. In a quadratic function, the domain is going to be the set of all real numbers, right? Just like that last one we looked at. Where was it? I can get rid of that, and I can put the... There we go. Right. I can zoom in, I can zoom out infinitely. I can still going to have numbers for x as far as I'd like to go. And redo, come back to here, right? So the domain is going to be all real numbers. What about the range? Well, we look for that lowest point of the graph. Lowest point of the graph, there we go. Hopefully it's still red, it is. Our lowest point of the graph is -4. Every other y is going to be part of this function going forward, all the way up. Nothing below -4. So what does that tell us? It tells us that our range is y such that y is greater than or equal to -4. Here, I've restricted it a little bit, right? Now this is a portion of that graph. So now I've got this inequality that has two pieces. Our domain. Our domain goes from here, -4, and it only goes to 2. So our domain is x, such that x is greater than or equal to -4 over here, less than or equal to 2 over here. Now what about our range? How does that change here? Red. I wish it would stay, but it doesn't, so our range is just here, right? Between those two red lines. Nothing excluded from this. It's greater than or equal to -4, less than or equal to 5. Same picture, except now I've got these couple of open circles here, right? We're going to have to deal with those open circles. Here and here this time. So how does that change things? Well, our domain, -4 and 2, both of those pieces are not part of the graph anymore. So it's not less than or equal to on either piece. It's just less than. So x, such that x is greater than -4 and less than -2. Remember, less than is and, greater than is or. Or means they're together, and means they're apart. Well, just don't even think about that. But what about the range? Well, -4 is still part of the graph down here, right? This point is still part of it. And whatever that is, I don't know. Oh, look at that. Oh, that was horrible. I didn't like that. Let's go back to my line. I could have used this one, right? And then it would have been there. Yeah, look at that. All right, a little easier to do. All right, so -4. That's the lowest point of the graph. But up here, right, when we get up to the top here, those 2 points are not part of the graph. So this is y, such that y is greater than or equal to -4, less than, just less than 5, because both of these circles are open, both of them. All right, this is the square root function. This is what it looks like. Take a look at the graphs. What happens here? Here, our domain starts over here. What is that? It's hard to see. Weird one. That's right. I'm going to keep using that. Right? Our domain starts over here, and it goes forever this way. Ooh, that was a line. Didn't want that. Wanted my pen. There we go. It goes forever in this direction. So our domain is x such that x is greater than or equal to -4. We had a filled in dot here. Nothing below -4 is part of this graph. Every part of the domain, every x value we can have is going to be greater than. What about our range? Well, our range, let me see if I can. The range. How does the range change? Well, the lowest point of this graph is right here at -3. There are infinitely y's going up. This graph goes on and on and on forever, no matter what I did. Here, let's see if I can. Why did that come back? Let's still hide it. Undo. Go back to the. Okay. Well, that's weird. Oh. Okay. Maybe that's the one. Yeah, that's the one I wanted. Sorry about that. Square root function. Again, if I scroll, zoom out, now it goes slowly, but the y's go on forever as well. Just wanted to show that. And go back to here. All right, so how do we write that? Our domain is x such that x is greater than or equal to -4. Range y such that y is greater than or equal to -3. Piece of the graph. This is a portion of that square root function. Both g and h are colored in. They are parts of the graph. This just changes to an inequality rather than just a greater than. So x is between -4 and 6. X is between -4 and 6. All right. Between there. And our range is between -3 and is about 1.5. You really got to kind of look at it and see what it is. If that's 0 and that's 2, 1 is here, that's 1.5. So about 1.5. It wasn't exact, but close enough for government work. Well, if I put that open hole over there, now this is not part of the graph. So our domain is greater than or equal to -4. G is still part of it, but less than 6, not less than or equal to, because this point here, 6, 1.5, is not part of the graph. Same thing with the range, greater than or equal to -3, less than 1.5. All right, so your assignment for tonight is on Delta Math. It is due by 5 p.m., and that's when it's due. We're going to be a little more strict in the things that we do, and the way I do it here. Um, it's just the way it is. It's the way it's got to be. So, after watching this video, please go. And this video, for those not in class today, will be on Delta Math as well, so I can be assured that you have watched it. So, have a great day, everybody, and I'll talk to you soon.